The shipment of structural steel arrives on site, and the crew starts erecting the first columns. But as you look from the foundation plan to the actual anchor bolts, your stomach sinks. The bolt pattern doesn't match the column base plate. Was the steel fabricated wrong? Or did you misread the drawing? This is the moment every site engineer fears, and it happens more often than you think. The ability to correctly interpret working drawings isn't just a skill. It's your primary defense against costly, time-consuming, and sometimes dangerous errors on site. In this video, I'm going to give you a battle-tested, systematic framework for understanding working drawings. This isn't about passively looking at lines. It's about actively interrogating the documents to extract the exact information you need to build what the designer intended. We'll cover how to approach the set, what to look for in each discipline, and how to spot the red flags that most beginners miss. First, let's establish what we're dealing with. A complete set of working drawings, also known as construction documents, is a package of interrelated documents, not a single sheet. Your very first action upon receiving a new revision should always be to go to the title sheet and find the drawing index. This is your master table of contents. It lists every single sheet organized by discipline: architectural, structural S, mechanical M, electrical E, plumbing P, and so on. A pro tip from veteran project managers: immediately check the revision block on the title sheet and on each individual sheet you use. The revision cloud is a dashed cloud around a modified area with a revision tag like REL or issued for construction. Using an outdated revision is the single most common and catastrophic mistake a site engineer can make. Before you do anything else, ensure you have the latest issued for construction set and understand what was changed from the previous version. This simple habit will save your career. Now let's dive into the architectural drawings. As a site engineer, you might think these are just for aesthetics, but that's a dangerous misconception. The architectural drawings establish the spatial and dimensional framework for the entire project. Start with the site plan to understand the building's orientation, setting out points, and finished floor levels relative to the benchmark. Then, move to the floor plans. These are your primary guide for room layouts, door and window locations, and wall types. Pay extreme attention to the dimensions. Are they to the face of the wall, to the center line, or to the finished surface? This matters immensely for coordination. Next, study the elevations to understand the external finishes and the building's overall form. But the most critical parts of the architectural set for you are the sections and details. A building section cuts through the entire structure, revealing the vertical relationships between floors, the roof structure, and ceiling spaces. The details, like a window jamb, parapet, or a stair connection, show you how materials interface. Your job is to constantly cross-reference these architectural details with the structural details to identify clashes, like a structural beam that conflicts with an architectural bulkhead. This brings us to the heart of your role, the structural drawings. This is where your focus must be laser-sharp. The structural set details the skeleton of the building, the elements that ensure its stability and safety. Begin with the general notes and specifications. They contain vital information on materials' concrete strength, steel grade, reinforcing bar types, design codes, and construction tolerances. Then, move to the foundation plans. You need to identify every footing, pile cap, and mat foundation, understanding their dimensions, top and bottom elevations, and the reinforcing steel schedule. The foundation plan will direct you to specific cross-sections and details for each element. Next, the framing plans for each level show the layout of beams, columns, and slabs. You must learn to read the member callouts. A callout like W16x26 indicates a wide flange steel beam 16 inches deep weighing 26 pounds per foot, while a callout on a concrete beam will point you to a beam schedule detailing its size and reinforcement. A common and serious drafting mistake is a dimension discrepancy between the architectural grid and the structural grid. It is your duty to find these clashes before concrete is poured or steel is erected. Always have the architectural and structural plans side by side to check that columns align and that beams don't protrude into required spaces. But the coordination doesn't stop there. The third critical layer is the MEP drawings: mechanical, electrical, and plumbing. These are the circulatory and nervous systems of the building, and they must fit within the architecture and structure. The MEP trades need space for their ducts, pipes, and conduits, and they often require large openings in your carefully designed beams and walls. You will find these on the MEP floor plans and reflected ceiling plans. Your role as the site engineer is to facilitate coordination. For example, you need to ensure that the 12-inch duct shown on the mechanical drawing can physically fit in the ceiling plenum shown on the architectural section, while also clearing the structural beam below. Look for sleeve and embed schedules on the structural drawings. These indicate where MEP trades need to pass through foundations, walls, and slabs. A missed embed is a massively expensive problem to fix with core drilling later. The secret to mastering this is to attend and lead coordination meetings, using composite drawings or a BIM model to visually identify and resolve these spatial conflicts before they manifest on site. So, how do you synthesize all this information into daily site operations? You develop a rigorous personal checklist. First, for any new activity, gather all relevant drawings. If you're setting out a wall, you need the architectural plan for location, the structural plan to see if it's load-bearing and what the supporting element below is, and the MEP drawings to see if there are any services or conduits running within it. Second, never ever take a dimension from a drawing by scaling it. Always use the written dimensions. If a dimension is missing, that is a request for information you must send to the consultant immediately, not guess. Third, constantly look for references. A detail might be referenced as 3/A4.1, which means detail 3 on sheet A4.1 of the architectural set. Follow these references relentlessly. Fourth, understand the hierarchy of documents. In a conflict, the structural drawings typically take precedence over architectural for load-bearing elements, and the written specifications often take precedence over the drawings. Finally, document everything. Mark up your own set of drawings with as-built conditions and take photos. Your meticulously maintained site diary and marked-up drawings are your only protection in a dispute. This proactive, questioning approach is what transforms a junior engineer into an indispensable project leader. In conclusion, interpreting working drawings as a site engineer is an active, continuous process of verification and coordination. It's about understanding the intent behind every line and note and foreseeing how the information on one sheet impacts the work on another. You are the final link in the chain, the last line of defense against errors that could compromise the entire project. By adopting a systematic, detail-oriented, and skeptical approach, you build not just structures, but a reputation for reliability and excellence. Now I want to hear from you. What is the most challenging drawing discrepancy you've ever encountered on site? Was it a level difference, a grid line shift, or a missing structural element? Share your war stories in the comments below. We can all learn from each other. If this guide has made you more confident in your ability to read drawings, please hit the like button and subscribe to the channel for more content that empowers your engineering career.